Welcome to the deep dive. Today, we're jumping into VXLAN, that's VXLAN. Now, it might sound a bit technical, maybe even jargon heavy, but honestly, if you're dealing with modern networks, especially cloud or big data centers, you really need to get your head around this one.
Absolutely.
We know you want the key info, the core stuff, without getting totally swamped. So our mission today is to break down VXLAN, explain why it's so important, maybe share a few surprising bits. We're drawing from Understanding VXLAN Networking Protocol. Ready to dive in?
Let's do it. You know, the reason VXLAN even exists is because we kind of hit a wall with the older stuff.
Right, like traditional VLANs,
Yeah.
the 802.1q standard.
For exactly this. They've been solid for segmenting traffic for ages, but they have this hard limit. You only get 4094 VLAN IDs, max.
Which sounds like a lot, maybe, but I guess not for huge setups.
Not nearly enough. Think about a massive data center or a cloud platform. You've got potentially thousands of customers, right? Each needs their own private, isolated network. 4094 just doesn't cut it anymore. It's like trying to assign unique street addresses in a giant city with only a few thousand numbers available.
Yeah, you'd run out fast. Okay, so the number limitation is a big one, like that building with only so many rooms needing to house, well, everyone.
Exactly. And it wasn't just the numbers. Managing these huge layer 2 domains, which is where VLANs live, gets really complex and frankly difficult to scale well, especially when you have multiple tenants sharing the same gear.
And I suppose virtualization and cloud stuff moves much faster than traditional networking was built for.
Precisely. That static nature of VLANs just didn't fit the bill for dynamic virtualized environments. So that's where VXLAN comes into the picture. It offers a way more scalable, more flexible solution.
A solution built for today's needs.
Right. VXLAN lets you create those layer 2 networks, the kind your apps and VMs often need, but it runs them over an existing layer 3 IP network. You're building virtual networks on top of your physical one.
Virtual extensible LAN. That name makes more sense now. The extensible part is key, isn't it?
It really is. That's what lets us break past those old limits. It seems simple conceptually, but it unlocks a ton of capability.
Okay, let's dig into these VXLAN basics then. Our source mentions it's defined in RFC 734-8, so it's standardized.
Yep.
And it calls it an overlay technology. I like thinking of it like laying down new lanes on an existing highway.
That's a good way to put it.
This overlay takes our normal layer 2 Ethernet frames and sort of packages them up inside layer 4 UDP packets.
That's the core idea, encapsulation.
And there's a specific port, 4789. So it's like putting your local package, the Ethernet frame, inside a bigger shipping box, the UDP IP packet, so it can travel across the wider network, the layer 3 part.
That analogy works really well. That encapsulation is the magic trick. It lets us tunnel a layer 2 over layer 3. Now let's look at the bits and pieces that make it work, the architecture.
Okay.
Our source breaks it down nicely. First up, the VNI VXLAN network identifier.
So that's the replacement for the VLAN ID?
Kind of, yeah, but on steroids.
Yeah.
Instead of that 12-bit VLAN ID giving us 4094 options, the VNI is a 24-bit field.
24-bit. Okay, how many segments is that?
About 16 million.
16 million.
Sure.
Whoa. Okay, that's not just a few more rooms. That's like building countless virtual cities.
Exactly. That scalability is just massive. It basically removes that old limitation entirely. You could give practically every server its own isolated segment if you wanted to.
Mind-boggling. Okay, so VNIs give us the scale. What's next? VTEPs. VXLAN tunnel endpoints.
Right. The VTEPs, these are the guys doing the work at the start and end of the tunnel.
Are they physical boxes, switches, or
Yeah.
software?
They can be either, or both, actually. A VTEP can be a physical switch port, maybe a NIC in a server, or even a virtual switch living inside a hypervisor. Its job is the encapsulation wrapping the traffic up and decapsulation unwrapping it at the other end.
So they're the on-ramps and off-ramps for the VXLAN highway.
You got it. That flexibility means you can use VXLAN pretty much anywhere, from bare metal servers to fully virtual setups.
Makes sense. So VTEPs do the packing and unpacking. Then there's the underlay network. The source says that's just the regular layer 3 IP network we already have.
Yep, your existing routers and switches, the IP routing infrastructure, that's the foundation. It provides the basic transport.
Physical roads, basically.
Exactly. And on top of that, you build the overlay network. That's the set of logical layer 2 segments you create using those VXLAN tunnels.
So the overlay is like our private express lanes running over the public highway.
Perfect analogy. Private layer 2 lanes over a public layer 3 highway.
Okay, I think I've got the components. Now, how does the magic happen, as the source puts it? Walk me through that encapsulation step by step.
Sure thing. Let's take a simple example. Say a VM in what used to be VLAN 10 wants to talk to another VM. It just sends a normal Ethernet frame.
Okay.
That frame hits the first VTEP, the one closest to it. This VTEP sees the frame and says, this needs to go over VXLAN. It grabs the original frame, slaps the VXLAN header on it, importantly. This header contains the VNI, identifying which virtual network it belongs to.
The 16 million number thing.
Right. Then it wraps that whole thing original frame plus VXLAN header inside a UDP packet using port 4789.
Got it.
Then that UDP packet gets put inside a standard IP packet. This IP packet has the source IP of the originating VTEP and the destination IP of the VTEP up at the other end.
So the underlay knows where to send it.
Exactly. And finally, there's an outer Ethernet header added just for the next hop journey across the underlay network itself.
Wow, okay. It's like Russian dolls. Original frame, inside VXLAN header, inside UDP, inside IP, inside another Ethernet header for the physical trip.
Pretty much. And when that whole package arrives at the destination VTP,
It just unwraps everything in reverse, peels off the outer Ethernet, the IP, the UDP, the VXLAN header, until it gets back the original Ethernet frame.
precisely. And then it sends that original frame off to the destination VM. The source material has a diagram that shows this layering really clearly. You can see the original frame tucked safely inside.
And the cool thing is, the underlay network, the routers in between, they have no idea about the layer 2 stuff happening inside. They just see IP packets going between VTEPs.
Exactly. They're just routing IP. Now, the big question is, how does the originating VTEP know which destination VTEP to send the packet to? How does it find the MESC address of the target VM within that VXLAN segment?
Right. The intelligence, the control plane. The source mentioned something called flip and learn first. That sounds inefficient.
Yeah, it was the original approach. Basically, if a VTEP didn't know where a particular MAC address lived within a VNI, it would just encapsulate the frame and multicast it to all the other VTEPs participating in that VNI.
Like shouting in a crowded room, hoping the right person hears.
Kind of. It works okay for small networks. But imagine doing that in a network with thousands of VTEPs. That flooding creates a ton of traffic and load. Not very scalable.
Okay, so that needed fixing. Which brings us to EVPN, Ethernet VPN. The source says this is the modern way, using BGP.
That's the one. EVPN is widely adopted now. And yes, it uses BGP, the Border Gateway Protocol. That's the same super robust protocol that basically runs the internet, routing information between networks.
So we're using that internet scale protocol inside the data center for VXLAN.
Exactly. EVPN uses BGP extensions to share the MHASI address information and even IP address information between VTEPs. So instead of flooding, VTPs learn where IMIT addresses are through BGP updates.
Oh, so it's like they subscribe to updates, like a directory.
That's a great way to think of it. A distributed directory service for M addresses within the VXLAN segments. A VTEP can just look up where a MAC address is, or learn it via BGP, and send the encapsulated packet directly to the correct destination VTIP.
No more shouting in the crowded room.
Right. It dramatically cuts down on that broadcast, unknown unicast, and multicast, what we call BUM traffic.
Yeah.
Makes VXLAN way more efficient and practical for large dynamic environments.
Much more elegant.
Oh,
Okay, makes sense. So let's boil it down for everyone listening. Why should you care about all this? What are the real world wins?
well, the benefits are pretty huge, and they directly fix those VLAN headaches. Number one, scalability. We keep saying it, but going from 4,000 segments to 16 million, that's the game changer for growth.
Yeah, that number is hard to ignore, especially for cloud providers.
Absolutely. Which leads straight into multi-tenancy. VXLAN is perfect for cloud platforms. It lets providers carve up their shared infrastructure into completely isolated layer 2 networks for each customer, secure private virtual networks running side by side.
Like secure virtual apartments in one big building. Keeps everyone separate.
Exactly. Then there's the layer 2 over layer 3 capability. This is massive for workload mobility.
Explain that a bit more. How does that help?
Okay, imagine you need to live migrate a running virtual machine, maybe for maintenance or load balancing, from one server rack to another. But those racks are in different layer 3 subnets.
Right. Traditionally, that's a pain. You'd have to change the VM's IP address, maybe.
Often, yes. Or do complex L2 stretching. But with VXLAN, because you're tunneling layer 2 over layer 3, the VM's layer 2 network effectively stretches across those layer 3 boundaries. You can move the VM, and it keeps its IP address, its MSC address, everything. No reconfiguration needed.
Wow. Okay, that's seamless mobility. Huge for flexibility, disaster recovery.
Invaluable for those things. It's like moving your desk to a different floor, but keeping the same phone extension and office number.
That's a great analogy. And the source says VXLAN is inherently cloud and data center ready, which seems obvious now.
It really is. It was practically designed for these environments: scalability, multi-tenancy, agility. It fits perfectly with software-defined networking, SDN, where you're managing that network through software.
It decouples the virtual network from the physical one.
Precisely. That decoupling gives you the flexibility of modern infrastructure demands.
So where are we actually seeing this used? Give us some concrete examples.
Well, the most obvious is data center network virtualization. That's kind of its home turf. Abstracting the physical network, creating logical networks on demand.
Making the data center network more agile, easier to manage.
Exactly. Faster service deployment, better resource use. Then, as we said, multi-tenant cloud platforms. Think OpenStack, VMware, NSX, public cloud providers. VXLAN is fundamental there.
Providing that necessary isolation between customers.
Another cool one is layer 2 extension between geographically remote sites.
So it's stretching a VLAN across the country, essentially.
Pretty much. Instead of needing expensive dedicated circuits, you can tunnel your layer 2 network over the existing internet or WAN connection between your sites using VXLAN. Great for DAR or maybe linking campus buildings.
That's powerful. Bridging L2 over L3 boundaries, potentially over long distances. The source also lists overlay networks in SDN environments, which we touched on.
Yeah, VXLAN is often the overlay technology of choice in SDN deployments.
And finally, service provider NFV network functions virtualization.
Right. Service providers are virtualizing things like firewalls, load balancers that used to be dedicated hardware boxes. NFV needs a flexible, scalable network underlay, and VXLAN provides that.
Okay, so it's really showing up everywhere in modern infrastructure.
It really is.
So, wrapping this up, VXLAN is clearly this powerful overlay protocol. It smashes the limits of old VLANs, gives us massive scale, true multi-tenancy, and that crucial ability to run layer 2 networks anywhere over an IP network.
And especially when you pair it with a smart control plane like EVPN, you get scalability and efficiency. It's foundational for today's data centers and clouds.
Absolutely. So hopefully you feel you've got a solid grasp on VXLAN now, why it matters and where it fits in. It solves real problems. But here's something to think about as we finish. We've talked about the power of creating 16 million isolated networks. How might that ability, the sheer granularity, change how we think about designing applications or even network security in the future? Could we see entirely new ways of segmenting services or protecting data emerge simply because this level of isolation is now possible? Something to mull over. Thanks for joining us on the deep dive.